Hello there everyone, it's uxwbill here once again, and tonight I have something a little bit different for you. But before we get started, I want to talk about safety. Specifically, I want to talk about electrical safety. When you're working with any sort of electrical device, be it battery operated, plug into the wall, whatever, your safety is very important. You can replace equipment, you can replace stuff that you screw up, but you can't replace yourself, you can't replace your family, and you can't replace your friends. So make sure, if you want to do electronics work, and I encourage anyone who's reasonably intelligent to at least try, make sure that you're not doing anything that you're simply not ready to do. Be careful first and foremost. Don't take unnecessary risks. Don't do anything stupid. Use your common sense, and if you think you're in over your head, get qualified assistance. With all that out of the way, tonight's episode of Kitchen Table Electronics Repair is actually taking place here in the new garage, and I've got something a bit different here. As you can see, these are all electric neon signs, all of them advertising automated teller machines at one point, or at least that's what they used to do before they stopped working. Now, I am not a big fan of working on high voltage electronics, be they automotive ignitions, neon sign transformers, oil burner ignitions, although those are getting much rarer, thankfully. I'm not afraid of electricity per se, but I always treat it with respect, and I will admit that I'm kind of a chicken. I don't like it when things go bang all of a sudden. I once plugged in a UPS that had spent several days underwater in a flood, thinking that would be okay after I cleaned the circuit board, and I didn't even hide too far away from it, and it went off with a big yellow flash and a pretty impressive arcing noise followed by a bang. I'm also a pretty lousy dancer. I dance like I have about 10 left feet, and my dancing most assuredly does not improve when I'm being driven by a high voltage electrical source. So I'm not crazy about doing it, but I let myself get talked into almost anything. Some people can talk me into doing about anything, and that's the story behind these signs. All of these signs were basically run 24 hours a day until one day they stopped working. They just plain went out and they quit functioning as normal. Now for the two over here, one of these was plugged into an outlet that was backed by a generator, which was admittedly not the best idea, but I wasn't the person in charge of or responsible for these signs. But a very interesting behavior was noted when the generator would perform a test. After the changeover switch had clicked and the generator was coming up to speed, these formerly dead signs, or this one formerly dead sign, would come back to life for as long as the generator was running. And the only thing that was different about it, the generator didn't have quite the smooth sine wave that is found on a normal AC power line that's being powered by commercial utility power. Its output was somewhat uneven until it had gotten up to speed, and its output was also somewhat uneven based on how heavily it was loaded. So whatever fault was being incurred with these power supplies on these neon signs was enough to keep them shut down in normal operation, but if you fed them with slightly screwy power, they would come up and work normally. So what's going on with that? Let's take a closer look at these. Here you can see a study in the wonders of vertically integrated manufacturing. As you can see, this sign claims that it was made by GHN Neon Incorporated, who is a subsidiary of Everbright in Garden Grove, California. The sign was made in the US. Look down here at the transformer. The transformer is made by Evertron. Evertron is a division of, you guessed it, Everbright Electronics. And to my almost undescribable surprise, look at where that power supply says it's made. I really expected it would be made in China, but it was not. Now, it's no secret, I feel these signs are very, very cheaply made, and even to a certain extent, which I'll discuss in further detail later, I could see them being a potential safety hazard. But here you have the internals of the power supply. Once again, I want to make it very clear to anyone who considers doing this kind of work themselves. Treat line-powered equipment with respect, especially if it's broken, because a power supply that's functioning normally has probably discharged its capacitors and done everything that it was supposed to when it was shut off, though that is by no means guaranteed. But this power supply, which is broken, is in an indeterminate state. It could still have charged capacitors that could really wake you up and put a sparkle in your eye, or if you're not strong enough, or if you happen to get hit just the right way, could even kill you. So again, be respectful, don't do anything that you're not ready to do. There's not a whole heck of a lot going on in these power supplies. It looks to me like it's kind of a cheap design, but I wouldn't call it a terrible design. You have the incoming line power right here, some filter capacitors. There's a fuse on the board that should blow if anything goes seriously wrong. Those two black things there are the rectifier diodes. And then over here, you have the portion of the power supply that's responsible for generating the high voltage. This is what you call a switch mode power supply. And in a switch mode power supply, the theory of operation is simple. One or more transistors is switched on and off at a varying rate by a controller. And the controller varies that rate in response to how heavily the supply is loaded to keep the voltage at the proper level and to deliver the correct amount of current. That controller in this setup is actually an international rectifier part. It is the black 8-legged chip that you can see there in the middle of the board underneath the heat sinks. And that chip contains several different things. It contains a mechanism to start the power supply. It contains safety circuits to shut the power supply down in the event of a problem. And it also contains a timing generator, in this case a 555 timer, that is used to provide the switching frequency output for the transistors. The transistors, also international rectifier parts, are right here. And they are probably putting out about 300 volts total. That voltage goes to this transformer right here. And this thing is not unlike a modified television flyback transformer, or as they're known in the rest of the world, an LOPT, or line output transformer. This thing takes a couple hundred volts off of the power supply board and steps it up to the 5 kilovolts that is required to operate this sign. Now this supply is current limited. It only puts out about 27 milliamps at most, and if it exceeds that limit, it'll shut down as a measure of protection, assuming that something is wrong. But that's still quite enough to give you an impressive jolt. So again, be careful. Now the problem with these supplies was pretty easy to trace down. There's nothing on this board that was burnt or blown off or obviously distressed. So it could really only be one thing, and as it turned out, every electrolytic capacitor on this board was bad. So I replaced all of them on the other sign. Compared to the others, I have no idea where this sign was being kept, that it was so filthy dirty. I can only guess that perhaps Oscar the Grouch has an ATM in his garbage can, and this thing spent many years down there advertising that fact. This sign, after having its power supply completely recapped, is completely functional, and the power supply appears to be working normally. However, things are not quite perfect yet. Let me show you what happens to this sign when it's been operating for a little while. When this sign is first connected to AC power, the power supply starts up. Everything seems okay, yet there are some subtle indications of trouble. The first two letters in the acronym ATM glow the normal reddish-orange neon color that you would expect. Now the camcorder doesn't pick it up, but the M is a different color from the rest. And after a couple moments of operation, the sign becomes unstable. There start to become hissing noises from the neon tubing, and the ATM sign itself begins to flicker. After a while, something starts smoking, which it's doing right now. So something is definitely getting hot here, but it's not the power supply. The power supply seems to be working 100% correctly. In an impressive display of bravado, especially considering the source, while this thing was operating, I put my ear up to it to listen to the power supply very carefully and see if I could hear anything that indicated the power supply itself might be in distress. The power supply itself seems to be working normally. I have not exactly pinpointed the source of the smoke, but I believe that it's actually emanating from the neon glass itself. Specifically, I believe it's coming from these contact points where the various electrical connections are made. There is evidence that some of these have been very, very hot. This one over here in particular was melted on, and I could not get it to come loose, and in fact it has melted itself into place once again. So that's why I feel these signs, even though they're not cheap, they really are kind of cheap junk. They really don't seem like they were built with a strong focus on safety in the event that something went wrong. And I'll show you why I say that. Whenever high voltage electricity is in use, I really expect to see proper connections and special attention paid to insulation. And they certainly paid lip service to it here because they put these nice insulating boots on, and this is pretty decent high voltage wire. Looks not unlike a modified spark plug cable. But when you take this boot off, there's evidence of dielectric grease, which is another good thing. And I thought that there might be dust or something in here that was causing the smoking. No, there's not. Look at that. Do you believe that? There is no proper kind of high voltage connection here. The wires are simply twisted together, and that is how I found it. That is how all three of these signs have been constructed. And to me, that is ridiculous. There's something strange that's going on here, too. I don't know what these sign connections looked like when they were brand new. Yet, as you can see, the wiring coming off of the transformer is nice, shiny, and clean. Yet the wiring going to the actual filament inside the tube is not. It's black. And I don't know if it's black because it's oxidized, or if it's black because when they were painting the parts of the tube that are supposed to be opaque, if they overshot it a little bit. But I believe that that is probably what is causing the smoking. And so in an effort to try and continue fixing this sign, I will have to clean up these connection points and see if the behavior improves. The third sign is of a vastly different design as compared to the first two. Oh, it's still very definitely cheaply made. There can be no mistake. The connection points are still simply twisted together. And the power supply has been made a little more cheaply as well. It's still made in the US. You can see that it's gotten thinner. You can also see that there are no vent holes anywhere on it. So it has the perfect opportunity to cook itself to death after a couple of years of continuous operation, at which point it'll have to be replaced. And given what the transformers seem to cost, you'd almost be money ahead just to buy another sign. Again, it's just kind of ridiculous. This sign was completely lifeless when it was connected to power, and I soon found out why. I took the power supply apart, which was the easy part, and I found that the line fuse protecting the power supply had blown. However, an ohmmeter test conducted on the rest of the circuitry after the fuse shows that there is at least no hard short. There could still be something breaking down under load. And it has to be said at this point that a fuse rarely fails just because of fatigue or age. It can certainly happen. However, usually when a fuse blows, it's because there is a problem, and that problem needs to be found. So if you are working on a device that's blowing fuses, resist the temptation, even if you think you have no other option at that point, to ever replace a fuse with anything conductive that is not another fuse, and a fuse that has different, usually higher, voltage and current ratings than the one that was in there. Don't do that. It just leads to danger. Even if the device seems to start working, you're just asking to have some kind of an electrical fire. I believe that this sign will run again after the fuse is replaced. There's really a lot of strong evidence here that the fuse just gave up because of age, fatigue, or maybe even someone doing something stupid. Well, that's pretty much everything there is to this video. Thank you for watching it, and if you have a comment, feel free to leave one. I'll tell you what, Bizarre Furhead, he has got such a perfectly matched outfit. It's just unbelievable.
I'm a lumberjack and I'm okay.
No, you're not.